Thank you for joining today's Protecting Identities and Secrets in a Multi-Cloud Environment with HashiCorp Vault webinar. This webinar is being recorded and the recording will be sent via email to those who registered within 1 to 2 business days. Joining me today is Luke McCleary, who is a Senior Solutions Engineer here at HashiCorp, as well as Dan Fedek, who is also a Senior Solutions Engineer here at HashiCorp. In this webinar, we will discuss how identity-based security using HashiCorp Vault strengthens security controls while enabling a highly dynamic and distributed application environment. Lastly, please type your questions in the Q&A box and we'll answer those questions during our Q&A session at the end. With that, I'll turn it over to you, Luke.
Thank you, Bria. Welcome, everyone. Thanks for making it to the webinar today. Good afternoon or good morning, depending on where you are today. As Bria said, my name is Luke McCleary. I'm a solutions engineer here at HashiCorp. And today we're going to be talking about identity management in kind of a multi-cloud world and how that relates to secrets and secrets management, also, of course, in a multi-cloud world. So your presenters today are myself, of course, Luke McCleary, and Dan Fedek will be manning chat window. We're both senior solutions engineers here on the federal team, but we can answer any of your questions regardless of kind of the sector you may or may not fall into. Getting started, I always like to kind of start a presentation like this off with kind of a question of, how or why. Why would you guys show up to it? Why would we have it? And likely the answer to the why question is because we live in a world with an increasing number of threats. I'm not going to read all these stats off to you, but I think the one that's most relevant to us today will be this kind of stat around web application breaches, where more than 90% of them are related to stolen credentials. And if we can do anything, in our positions and our roles in organizations to reduce this, that would go a long way to kind of stopping breaches somewhere within the attack framework, the threat chain, and ultimately, make our organizations more secure. So we want better secrets. We want higher quality secrets. We want to be able to just manage them, easier in a more governed fashion. And that's really difficult in the kind of modern, dynamic, multi-cloud world that we live in, because we're used to a more simple framework. A lot of our systems were developed around an identity system that was easy. In the old world, when I got started, data centers were on-prem. There was no cloud. IP addresses for applications were static. Our network devices were static, and our user identities pretty much all lived in one place. It was an Active Directory or an LDAP type directory system. And this was really the entire landscape of identity. We could rely on IP addresses not changing. We had one place to look up who people were and what their roles were. And it made basically identity management pretty simple. When we compare that to the modern landscape, it's much more complex. Every single one of our cloud providers has its own directory service, whether that's something like IAM for Google or AWS, which confusingly are named the same, but are completely different. There's Azure AD for Azure, of course. They all have their own different OIDC providers for each of these. And then under those directories, they all have their own secrets management solutions. They're all proprietary. They don't interact with each other. You've got things like AWS KMS, Secrets Manager, Parameter Store. That's just one cloud. You go over to Azure, you got a whole different set of services, Key Vault, so on, similar services in Google. So we've got all of these different components. And to make things even more complex, none of the services are really staying in the same place anymore. They're moving around, they're growing, they're shrinking, their IP addresses are changing constantly. And that IP address can no longer be relied on as a reliable identity for an application or a network device. So we need a better way of establishing identity, authorizing and authenticating different devices and users. And we need a way to do this across clouds. So the first kind of component of Vault, the first piece of Vault that makes it a powerful tool is its capability to broker authentication and authorization and identity across clouds. What this means is Vault sits between your user, your application, and the array of different services that exist in the cloud, and allows a very simple authentication with Vault to be turned into an authentication with any number of brokered identity services behind it. So you can have a single identity. Say you have a web application and its identity is a JOT token. And using that JOT token, that web application can request services from AWS, Google, GCP, Active Directory, and it doesn't need to have native managed local credentials for each one of these different providers. It's all handled through Vault. So we kind of bring it together. It creates this kind of triad where Vault is that broker that sits in the middle, where at the top we have clients. Clients can be people, they can be containers, EC2 instances, applications, and these clients need access to an array of services in the cloud. So they go to Vault, they authenticate with any number of supported methods, but they only need one method to authenticate. And once authenticated, they can leverage the brokered backend of all the different integrated solutions within Vault to pull any resources it needs from any cloud. Examples of this include things like taking an EC2 instance, using its instance ID to authenticate with Vault to pull an Active Directory certificate from on-prem, or using the Active Directory credentials on a machine to make a query against an AWS RDS instance. So there's a ton of applications for this that aren't even necessarily directly related to the way that Vault handles and manages secrets. But it is the first piece of the puzzle that we have to solve before we can really truly get into managing secrets and just general security across the different clouds. So we have to broker them first. Any questions so far with the identity piece of Vault, solving that multi-cloud identity crisis? Okay. So the second piece of this, and then we'll just assume that we've solved the identity piece, is actually managing credentials themselves. And as we did before, we can kind of start with the challenges associated with managing credentials in a modern world. I mean, honestly, most of these challenges have existed forever. Since the early days of computing, we've had, I won't read them all off to you, but basically governance challenges around our secrets, secret sprawl, reuse of secrets, the poor ability for us to pull them back when we need to, controlling when they expire. All of these have existed for as long as I've been in IT. But thanks to the myriad of new identity-based solutions we have in the marketplace, Vault is able to solve really all of these challenges with a single weapon that we call the dynamic credential. And as before, because Vault sits in between your application and the clouds and the secrets that generate, or the clouds and the services that generate secrets behind them, Vault can act as a broker, a steward of secrets, and add governance to secrets that don't natively have governance capabilities. So with dynamic secrets, the secret itself does not exist before it is requested, and it does not exist after its time to live has expired. All of these credentials are generated on the fly. They are ephemeral. And that means that we can dramatically reduce the attack surface of our organization when it comes to secrets, because we get to control and ensure that our secrets expire in a timely manner. Many of those web application breaches and breaches in general occur because secrets live too long. We're talking months or years in many cases for organizations where highly privileged secrets have the opportunity to be leaked in an email, a text document, a Git commit. There's just so many ways that we can lose a credential that it's critical we tighten up the ability for those credentials to, live very short lives. So we now have this framework where a user from really any cloud can authenticate using the native authentication method from that cloud and pull a credential from seemingly any other cloud. And these credentials themselves are higher quality secrets. They have time to lives wrapped around them. They're audited. They're revocable. We have policies around who can access which type of credential. We can even do things like ensure that certain credentials can only be requested at certain times of the day. Blank slide. And the market has recognized Vault as a leader in this space. We are far and away the most popular secrets provider in the marketplace today, with over 130 million downloads every year. And of course, trillions of secrets served, and we are in pretty much every single one of the the Fortune 100 today, in some manner of speaking. You probably can't get through a day without interacting with Vault in some way or fashion in your life. Talking about some of the actual use cases for Vault, now that we've established the identity engine, we've established what a dynamic credential is. So what kind of credentials can be dynamically generated, and how are they valuable for my application team, my infrastructure team? Some of the key use cases we see, especially starting use cases for organizations, revolve around three items: databases, PKI or public key encryption, and just general service accounts within your organization, things like Active Directory service accounts. So the first use case we'll discuss here is database credential rotation. Vault, via a plugin-based framework, can integrate with all of the modern, and some of them not so modern, database engines on the marketplace today. That includes everything from ultra-modern solutions like Snowflake to relatively contemporary solutions like SQL, CouchDB, Cockroach, MySQL, PostgreSQL, and even older systems like DB2. It's completely agentless. We establish a relationship with your database through a Vault service account, and from there on out, Vault simply acts as a broker to generate and destroy credentials based off of governance policies that we create within Vault itself. The benefit here being, especially if you're leveraging these dynamic credentials, we're dramatically reducing the amount of credential sprawl that you see in your database environment. And these are environments that traditionally have a lot of sprawl. Different DBAs are creating different types of accounts on different databases. There isn't a lot of ability to validate and verify that best practices are being followed because they're not particularly well unified. And that means you have a lot of different database credentials sitting out there permanently that may or may not be even actively used by anybody in your organization. So by funneling all of our credential generation through Vault for databases, it means that we can generate a very precise type of credential with a very defined capability via a SQL statement. And then we can ensure that it has a very tight life cycle. Maybe it only lives for a week, maybe it only lives for a month. And then Vault goes and makes sure that it cleans up that credential and destroys it at the end of its life cycle. So we don't have a bunch of long-lived credentials sitting out there just creating a larger attack surface for our organization. Similarly, we have the same capability to do this for many different types of service accounts. We can generate service accounts for pretty much any type of provider that you need them for. So we can create service accounts for Active Directory, cloud providers, really anything that we can integrate with from an IAM perspective. We can create a service account for, we can rotate that service account, we can ensure that it has a clean audit trail. And of course, most importantly, or maybe not most importantly, but very important in the modern era, we can establish a trail of revocability. So we can determine who requested credentials, when they requested them, what other credentials they may have also requested. And in break glass scenarios, we have the ability to revoke all of these credentials. We can revoke everything from a specific database, everything from a specific user, everything from a specific type of credential. So if I wanted to revoke all AWS credentials, I want to revoke all database credentials, I can do that because we have this clean audit trail and we are tracking all the credentials that have been issued by the system. And the final use case that we find is really compelling for organizations is the management of certificates. Specifically, certificates have become a challenge for organizations because there are so many more certificates that we have to manage than we used to. Everything is now TLS encrypted. Every single server pretty much has to have a certificate generated for it. And this wasn't really the case 10, 15 years ago. We used to just lean on self-generated certificates. They lived for as long as they needed to live. And that was kind of the end of it. But now we need very, precise, trusted certificates for everything that we roll out. And that means just simply a lot more certificates out there. And we need better control of how these certificates get generated. With Vault and dynamic certificates, we can ensure that certificates not only get automatically rotated, but we can ensure that they are generated the correct way with the correct fields filled out, and that they only live for a defined period of time. I'd say the bigger challenge with TLS certificates and just general certificates is that we're not doing a very good job of tracking when they expire. So I think we've all probably experienced an application in our environment going down because a cert expired. This is not uncommon. And the general downtime associated with an event like that can be anything from, a few hours to potentially days, depending on what the process is to get a new certificate into that machine. But with Vault, we can fully automate this process with our agent-based delivery system of certificates and our direct integration with certificate providers. We can create certificates, refresh them automatically, and ensure that your services stay up and secure. And a couple more of the more advanced use cases we see are around encryption. Vault can act as an encryption as a service engine where you send TLS encrypted payloads to Vault. We encrypt them with an encryption key that has been set up for your application. And then we send the payload back to you as ciphertext for you to store. This is very powerful for organizations that may not be experts in cryptography, but they do want to ensure that their data gets encrypted. With this methodology, you are ensured to have a fully validated encryption scheme with all the latest keys and capabilities without having to be that cryptography expert. And then the final use case is just general management of keys, whether that's managing keys in your cloud provider, like managing and rotating Azure Key Vault keys, KMS keys, and AWS, or integrating with more legacy infrastructure items like your storage devices, vSphere, and other KMIP compatible systems. Key sprawl is a big challenge for organizations as clouds have grown, and Vault can act as that centralized key manager to generate, rotate, and revoke keys, regardless of where you're running your system. So to kind of bring it together for the demo here, Vault's a really simple system. It's a node-based, scalable binary, which allows us to run a single set of services across all of our clouds to improve collaboration, security, identity management. It's really just a single unified tool set for secrets management and identity. And just kind of a closing thought here. A lot of organizations come to us after a breach and they want to understand how they can improve their security posture and prevent similar events from happening in the future. Roughly 80% of companies that experience large-scale breaches do come to us and make an investment in Vault. If you have any questions, feel free to reach out to me. either directly or in the Q&A session here we're about to roll into. I do have a demo lined up here in a few minutes, so if you guys want to throw any questions out there, we'll answer your questions, and then I can kind of show you a quick demo of the Vault UI. Bria, do you want to open it up for questions? Should we just look for them in the chat window?
Yes, there is one in the chat right now.
Gotcha.
In the Q&A.
I'm looking at the wrong chat window. Am I? I don't know.
See the same thing there, yeah.
There it is, Q&A, perfect. All right, are you able to send step over SDS? Sure, I can take a note on that one. Dan, I don't know if you already took care of that, but yeah, well, we can copy your email address and get that over to you.
Yep, there's some good documents on that.
Yeah, absolutely. Develop programs for enterprise plus development, HSM stuff. Do you have any more specific HSM type questions there? Michael Miller? I got you. Yeah, if you're looking to trial something specific, we can get in touch and we can kind of talk to your account team. There isn't like a license portal where you can just go and download licensing for any old purpose, but we can work with your account team probably to get you some additional testing capabilities. What's the difference between KV1 and KV2? So the KV1 secrets engine is, it has basically less features, but because it has less features, it's also faster and takes up less space. The KV2 introduces a number of capabilities like keeping a history of all of the entries into the engine. So you can have a version history basically of all of the secrets that have gone into that particular secret. That's the major difference between KV1 and KV2. So our general recommendation is if you don't project a need to be able to go back and look at the previous versions of a secret, to go with the KV1 engine, because it doesn't have to store as much metadata. It's a little faster. But if you do want that additional functionality, enable the V2 version of the secrets engine. Is app role best for Kubernetes? It's hard to say what's best. Best can be different for different folks, but I find that the best thing for Kubernetes is to use the Kubernetes-based authentication engine for, I think Dan might be helping you out with that one. We do integrate directly with the Kubernetes cluster authentication service, and allows you to transparently authenticate all the way from a container using a Kubernetes token all the way into Vault to retrieve a secret. And this can be done basically automatically and fully natively, so you don't have to worry about defining and managing app roles and updating credentials. Can you share any documentation on how to use Vault for AM users? I'll probably leave that one to Dan if he can find some documentation on it. If you guys want to leave email addresses or directly, I don't know if you can directly send email addresses. We can see if we can get back to you on some of these guys. I don't have any current examples of direct API usage. Vault for SSH. Yeah, there is a learn page. A lot of these questions might be able to be answered at some of our Vault learn pages. So if you if you head over to, I guess I can't see all the answers. Interesting. If you head over to the Learn page that I just sent over there, you can also just see it on the screen here. There's a bunch of different labs that you can go through with that will show you how a lot of this stuff works. There's one here for whoever kind of asked the question between the key value engines 1 and 2. So there's a lab for that if you want to check that out. There's also a lab on PKI. There's one for SSH sessions. So if you want to kind of see how that works, it'll walk you through that process. The Learn page here is pretty robust. It's got most everything you would want or need. I'll see if I can find the one on Kubernetes for you. I know we might have a separate section just for that, but
I did put something in for the secrets engine in the answers.
Gotcha. Okay.
To the Learn article.
Oh yeah, perfect. Perfect. All right. Let me spend a few minutes running through a demo real quick, and then if there are any more questions, we can answer those. And otherwise, I can let you guys go. So you guys should be able to see my screen still. This is a local Vault cluster running locally within my machine. When you interact with Vault, there's a few different ways you can interact, as we've noted here in the text window or the chat window. You can interact with Vault via directly the API. You can log into the UI. There's also the agent and a CLI that you can use. So there's lots of different ways that you can configure and request and store secrets in Vault. But for the demo today, we're just going to walk through the UI because it just presents better and is the least confusing way to do this. When you first log into Vault, you're going to be requested to authenticate regardless of the way that you want to interact with Vault. And here in the UI, it's going to ask me for basically a namespace or AKA an organization to log into. We have full multi-tenancy built into the platform. And then it's going to ask me to choose a method to log in. As we spent a lot of time talking about identity, you can see there's a lot of different ways that I can log into the system. I can use a native Vault token. I can use usernames and passwords. I can integrate with LDAP, Okta, a JOT token, any OIDC system, Radius, GitHub, just a ton of different ways that I can log in here. But just to keep it simple, I'm going to log in with the root token today. And we can see when we log in, we're presented with a pretty simple interface. When we land inside of Vault, we get presented with what are called secrets engines. And each secret engine is basically an integration for a different type of secret. So you have secrets engines for databases, key value stores, secrets engines for PKI or encryption. And what we're going to demo today is the database encryption engine, database secrets engine, as well as the PKI / certificate secrets engine. So if we want to interact with the database secrets engine, we click on databases, of course, and we can see that this particular instance of Vault is integrated with 2 different databases. One is a MariaDB, the other is a Postgres database. The integration is established via just a simple URL for connecting Vault to the database, plus a service account. This will be a highly privileged account that only Vault knows. And Vault will use this account to create and destroy credentials based off of the parameters that we provide the Vault roles. So with the relationship established, we can go to roles and we can see that we have a number of different roles created. And these different roles will, as the name implies, have different capabilities within the database. So if I want to give a certain user or machine read-only access to the Maria database, maybe I give it the analyst role. Or maybe if I have a particular admin that I need to grant access to a database, I give them a more privileged role, like the Maria DBA role. And we can see within these roles how they work. They're all just based off of SQL statements, which is why our integration with databases does not require an agent. We simply make calls in the native language to your database to assign a role to a user that is created on the fly, and then return that credential back to the requester within the Vault system. We're able to wrap governance around this by saying, maybe the credential only lives for a certain amount of time by default. It can be maybe renewed a few times and live a maximum of a certain amount of time. But this ensures that no credential lives forever. And that's probably the most important takeaway here, right? We want unique credentials every time they're requested. We want them audited, we want them revocable, and we want to ensure that they don't live forever. And that's really the power of this particular integration with databases. If I want to generate a credential, there's a lot of ways I can request it. In the UI, I can just hit the generate credential button. We can see it'll just generate a unique set of credentials for me. I see how long they live. And I also get a specific lease ID, which is tracked in the audit log and allows me to revoke this credential anytime I need to. The second use case we'll discuss here is the PKI or certificate-based integration. Vault can serve as either a root certificate authority or an intermediate certificate authority, depending on the needs of your organization. And either way, what Vault is able to do is establish guardrails around what types of certificates can be created and grant access to users to create those certificates. And by users, I mean, could be applications, could be human users, but it's all done through roles. Make sure I'm on the right one here. So I've set this particular instance up as an intermediate certificate, which means that Vault is issuing a certificate on behalf of another root certificate somewhere else. And these certificates are issued based off of these roles that control what type of certificate I'm allowed to issue. When I create one of these roles, I have dozens of parameters that I can configure to ensure that certificates are created in accordance with best practices for my organization. I can lock down which domains they're allowed to use and create certificates for. I can lock down serial numbers, just the really basic address and time to live options. I can, most importantly, again, ensure that certificates don't live forever. I'm not allowed to create a certificate that lives for 10 years. And of course, when we generate a certificate by selecting a role, that certificate is tracked and audited and is revocable here within the system. So if I want, let's create a webinar well, actually, let me show you what it looks like if I try to create a certificate that doesn't comply to this particular role. So if I want to create a certificate called webinar.luke.com, it's going to prevent me from doing that because I don't have permission to create any certificates outside of a very specific domain. So if I go back and I create the right certificate in the right domain, webinar.hashidemo.com, it will allow this because hashidemo.com is the only domain that I am allowed to create certificates for. So we can see the full certificate chain here. We have a serial number, expiration date, all the good stuff. I can install this into my application. I can have it delivered automatically through a Kubernetes integration or an agent integration. And that's really certificates, right? I can view the certificates that I've issued. They're both right here. And if I want to revoke one of them, that's available right here within the UI. Questions or comments here? All right. There aren't any other questions. We can let everybody go. I guess that's pretty much it.
Yeah, well, thank you so much, Luke and Dan. And thank you to everyone who submitted questions. I hope everyone enjoyed today's webinar. We'll make the recording available after processing it, which typically takes about 2 days. We'll send an email to everyone who registered with the recording link, and we'll also be on the HashiCorp YouTube channel. Thanks again and have a great day.
Thanks, everyone.